Okay.
Yeah, so as Heidi said, this is a talk on perspectives on machine learning and artificial intelligence from trainee radiologists. We were working with the National Imaging Academy of Wales, which is a branch of the NHS that does train clinicians into radiologists. So, oh, hang on, there we are. So just a quick introduction for anyone who might not be up to speed. Radiology is the diagnostic field of medicine. If there are any actual radiologists in this chat, they would be horrified that I simplified it down to that. But for the purposes of this talk, it's diagnostics. Machine learning and AI, there are going to be some people who are horrified at this, but for the purposes of this talk, it's really just a program predicting an output based on input data. If we use the term HCI, that just refers to human-computer interaction, so the way that people use devices, the back and forth between that and the feedback. And if you see the acronym NIAW, that stands for the National Imaging Academy of Wales, which, as we said, is a campus. It's over in Bridgend, and it's where clinicians come to train to be radiologists. So the motivations for this project, just really quickly, were that ML systems are pretty ubiquitous nowadays, especially in something like radiology, which is very technology centric. Clinicians have to know how they work, have to be, the term that we used is comfort leads to confidence. So if they're comfortable using them, they're happy that they know how they work, they tend to be more confident in the outputs that they get. Development education. So obviously, if we know how clinicians feel about this technology, anything good, anything bad, we can develop it further, we can make changes. And we can also potentially, since we're working with a training academy, highlight gaps in knowledge, maybe gaps in understanding that can be filled very easily in a syllabus. And finally, the boring bit, this needs to be the groundwork for a doctoral project that we are currently working on. So this is the National Imaging Academy campus. This is where we did our workshop. So the study design, as I said, what we did is a workshop. We worked with about a dozen, so a full cohort trainee radiologists in the first year of their radiology training. So they'll be qualified medical students, and then they'll go through 5 years of work with the NIAW. We developed 3 different types of activity that we did throughout the workshop. The biggest and by far the most important was discussion, because we felt that if we stimulated good and honest discussion, that would be where we get the details that maybe we weren't aware of. That's where people are going to be most comfortable. So we asked people to discuss examples of machine learning in the home and in the workplace, any good and bad experiences that they've had with machine learning, and what they think the impact of this is going to be in the future. We also wanted some quantitative, solid data that we can, actually analyze that is set. So we had some scoring activities. We did a simple word association exercise where we just said, we gave them a keyword from a computer science perspective and asked them to see what they thought the first thing that came into their head was. And we did a couple of 1 to 10 scales. In retrospect, this should have been a Likert scale. That was sort of a misstep by us, but it definitely still gave us something. So we gave them a prompt and said, how much human intervention is involved here? So is it a 100% machine automated product, or is it a 100% human process? And we gave them a few machine learning tools and asked them to scale it from 1 to 10 on how effective they think they are at doing their job. So we gave them a spam filter, we gave them word association, we gave them some image recognition, and just said, on a scale of 1 to 10, how good do you think they are at doing their job? And the last one was a bit of a Hail Mary. We gave them a very open prompt. We just said, design something that you think you would like to see in your job. Gave them a big piece of A3 and some marker pens and just said, have at it, because we feel that a lot of the time, if someone is really uncomfortable with a piece of technology, if they really don't like the way that it currently works, they will design something that they think should happen. And this can really throw out some interesting ideas for the development of new technology. So we did a 3-hour workshop. We collected all the audio, we analyzed it by hand. We came up with some themes, but before that, so we've split this into the quantitative results and the qualitative results. And we found some interesting things quantitatively. Certain things with the word association got what we'd expect. When we gave them AI, they came back with robot. When we gave them algorithm, they came back with maths. And when I say they, It was quite interesting. We tended to have sort of a 65 to 70% sorry, cohesive response. So a lot of people in the room tend to give the same answer for the same word. But there were some interesting ones that we tended to not expect. Obviously, in a computer science environment, when we think about black boxes, we tend to think about explainable AI and system, that sort of thing. And you begin to forget that a black box is something in the real world. So when we said that, people came back with aeroplane, they came back with car, and it took us a while to understand that they're using that from their experience rather than in a computer science way. With the scoring exercises, we got a lot of 6s and 7s, very few under 5, very few over 7. So there was this sort of inherent hesitation to give proper high or low scores. We're not sure whether this was a lack of familiarity with what we were asking them to do. We're not sure whether this was because they were in a group of sort of 10 or 11 of their peers, so they didn't want to give a high or low example because they may feel that they get it wrong, they've been shown up, something like that. But there did seem to be a slight lack of high scores for effectiveness and very heavily machine automated tools. And finally, with the design fiction, when we gave them this prompt, most of the time the response that we got was people designing an all-in-one system, so bringing lots of different things together into a singular place. So whether that is someone designed a robot that had an EKG, had a stethoscope, had something to do cannulas in it, so it basically replaced a med student. Someone designed an online portal where you could get prescriptions, you could get doctors' opinions, you could book appointments, surgeries, that sort of thing. So the big theme was centralization, bringing lots of different things into a singular place and sort of eliminating all periphery. So that was a big theme in design fiction that was quite interesting. With our qualitative results, again, we seemed to get a shared sort of response. When we prompted machine learning, almost everyone came back with a digital assistant. Alexa was name dropped most of the time. This may be because it's the most recognizable example of a new technology. You know, you've got it in your home, it recognizes your voice, it can link itself to all your different devices. Similarly, automation, when we asked for examples, tended to throw back examples where a few years ago you may have seen a real person that's been replaced. Like we got a lot of kiosks, like at Tesco's, the self-service, McDonald's, the self-checkout, that sort of thing. Those tended to be the big examples where a few years ago there would have been a person doing that for you, and now it's a machine. The more recent examples tended to be thrown out. And algorithms, an interesting one is it was associated with social media, and we pulled up a couple of articles that were about gaming social media. So if you're an Instagram influencer, if you're trying to be a TikTok star, you tend to use the word algorithm a lot as an explanation for how people can see your content more. And it seems to have become a sort of strong connection between social media and algorithms. When we ask people for good or bad experiences, e-prescription is not popular. I'm not sure if we've got any people who work in healthcare in this chat, but e-prescription is not a very popular system. It seems to be quite new, but it was supposedly full of bugs and that sort of thing. And when we ask people for a negative experience they have with machine learning and AI, a lot of them threw out specifically this or lots of NHS-based technology, whereas third-party things like WhatsApp and Zoom tended to be positive. So there's a sort of almost work-life balance relationship there, where work machine learning tended to be quite negative. And the final one is more of an overarching thing that we got, which is when you came out and said to someone, what do you think of machine learning? What do you think of AI? They were very positive. They were very, it's going to help us, it's going to improve our lives. But when we sort of circumvented that and said, oh, how much faith do you put in this system? Oh, if we were to have a machine doing this instead of a person, what do you think? The responses dropped massively in terms of positivity. So we came up with the term overt optimism, but inherent skepticism, where if you come one-to-one and say, is technology good or bad? They'll say good. But if you work your way around it, maybe if you ask peripheral questions, that sort of thing, the responses tend to be a lot more negative. So there was still an inherent sort of skepticism of technology that we found. So when we did some thematic analysis, we came up with 3 themes that were across all of the exercises, across all of the participants, that sort of came up again and again and again. And this is what we feel the research really showed. is that the one big thing is where does data come from? So participants know input, machine learning output. So we gave an example of Google Maps. You put in A to B and it says it's going to take 10 minutes. And they said, well, it's because it's a 10-minute long road and it's 60 miles an hour. But what they didn't anticipate was the sheer volume and variety of data that goes into a decision like that. So they seem to struggle with the idea that it takes your previous data of how fast you drive, it takes the weather, it takes how many users are on the road, it takes other users' data, and all that sort of thing. And there's a million different bits of data that go into this one decision, and that seemed to surprise participants of it's not just a singular input, it's millions and millions of inputs that are then synthesized into one answer. Shared experiences, as we said, a lot of people hesitated to give high or low scores, and they discussed absolutely everything. And so we think that whilst in the data, it did seem like a lot of people had the same experience, it would be interesting to do this again one-on-one, sort of interview style, to see if these answers change. And that's one of the big drawbacks of workshop style data collection. And finally, the perspectives on machine learning as a tool to be used seemed quite interesting in that there was a very low error acceptance. We used the example of a spam filter. If it recognizes 1,000 spam emails correctly, but one work email from your boss that contains something important and puts that into the spam filter, suddenly it's not a very effective device. Whereas if it was a person doing that, the error acceptance rate was much higher. The sort of tolerance for these systems making mistakes seemed very low from the responses we got. So there was the sort of perspective of, if we're getting a machine learning tool to do it, if we're getting an algorithm to do it, it should be good enough that it doesn't make these sort of mistakes, which could be seen as mildly unrealistic. But then we put it in the context of these are clinicians, and if they make mistakes, often they may be at fault, people could get hurt. So for them, the stakes of using these tools are much higher, and that may be one of the reasons that there was this inherent skepticism. So that's the research that we did. It seemed to mostly focus on these outward versus inward perspectives. And in the future, we're going to be working on maybe running a similar sort of thing with qualified radiologists. But there is immense potential for research in this area, and we're quite happy with what we did. So if there's any questions, let me know. Thanks very much.